All right, today we're going to pull back the curtain on something that literally shaped the internet as we know it. PageRank. It's the secret sauce that took web search from being a total mess and turned it into, well, something actually useful. Let's get into it. So try to remember, if you can, what the internet was like back in the 90s. You try to search for something, and it was a total gamble, right? You type in a query, hit enter, and just pray. And more often than not, what you got back was just junk. Totally irrelevant, useless, sometimes bizarre stuff. So what was going on? Why was it so broken? Well, the biggest problem was that the early search engines were, frankly, kind of dumb. They were incredibly easy to fool. See, they decided what a page was about almost entirely based on the words written on that page. And this one little detail created a massive loophole that people started exploiting like crazy. And that loophole got a name: term spam. People figured out they could totally game the system. They just crammed their websites full of popular search terms, thousands of them, even if their site had absolutely nothing to do with those words. You might be wondering, how did they do that without making the page look like a mess? The trick was pretty sneaky, actually. Let's say you wanted your website to rank for the word movie. You could just write movie 1,000 times, but make the text the exact same color as the page background. To you and me, it's completely invisible, but to the search engine crawling the code, it sees everything. The web was in chaos, and it desperately needed a new way of thinking. And that's where two Stanford PhD students, a couple of guys named Larry Page and Sergey Brin, enter the story. They came up with a radically different idea, a whole new philosophy for figuring out which web pages were actually important. Okay, so here's the absolute game changer. Their idea, PageRank, basically ignored what a page said about itself. Instead, it focused on what other pages said about it. A link from one page to another was treated like a vote of confidence, an endorsement. And, this is the crucial part, not all votes were equal. A link from a big, respected site was worth way, way more than a link from some random page nobody had ever heard of. To actually calculate all this, they came up with this really elegant analogy: the random surfer. Just imagine someone who is endlessly and randomly clicking on links, just jumping from page to page forever. The pages that this random surfer ends up visiting the most often are, by definition, the most important ones. Why? Because they have the most high-quality votes pointing to them. Now, in a perfect world, a nice, tidy little web where everything is connected, this works perfectly. Our surfer just bounces around, and their path naturally shows us which pages are central to the network. Those pages just rack up the highest scores over time. The only problem is, the real web is anything but tidy. Yeah, the actual web is a sprawling, chaotic mess. And it has some serious structural problems that could completely break this whole random surfer model. It turns out the web is kind of shaped like a bow tie. There's this big, dense core where everything is well connected. But then there are these giant sections where you can get in, but you can't get out. Plus, there are pages with no outgoing links at all. We call those dead ends. And even worse, there are spider traps, little loops of pages that only link to each other. Our poor random surfer could easily get stuck. And this wasn't just a small issue. It was a deal breaker. If the surfer hits a dead end, poof, they just disappear and their importance vote just drains right out of the system. If they get stuck in a spider trap, all that importance just gets hoarded and recycled in one tiny corner of the web, totally skewing the results for everyone else. The simple model was broken. So what was the fix? It was absolutely ingenious. They called it the taxation model. Instead of the surfer always following a link, at every single step, they have a choice. They can either click a link on the page, or they can just get bored and teleport to a completely random page somewhere else on the web. This little tax on link following is the magic key that ensures the surfer never, ever gets permanently trapped. And that teleport probability, that's the secret sauce. Typically, there's about an 85% chance they'll click a link and a 15% chance they'll just jump to a random page. That one small change prevents the whole system from breaking down and allows PageRank to be calculated across the entire messy real-world web. And PageRank worked brilliantly. Search results got incredibly good, incredibly fast. For a while, anyway. Because as we know, where there's a system, there are always people trying to game it. The war for the web was far from over. So with term spam defeated, the spammers had to evolve. They looked at the new system and realized, okay, if links are the new currency, we just need to figure out how to print our own. And this led to the rise of what we call link spam. They did this by building these massive structures called spam farms. Here's the basic idea. A spammer creates one target page they want to get to the top. Then they create thousands of other bogus supporting pages that do nothing but link back to that one target. All they have to do is get a few real links from the outside world, say from a blog's comment section, to funnel a little initial page rank into the farm, which then acts like a giant amplifier. And the impact was just mind-boggling. The entire farm is built to act like a giant lens, focusing all of the PageRank from its thousands of little pages onto that one single target. This could blow up a page's score by a factor of 30 or more, making a completely worthless page suddenly look like one of the most authoritative sites on the web. We were at risk of going right back to square one. So the search engines had to evolve again. They needed a new way to tell the difference between a legitimate, earned vote from a real person and a fake one that was manufactured in a spam farm. This arms race led to the next major innovation. Enter TrustRank. The core idea here is simple, but it's incredibly powerful. Instead of treating all pages as equals, it starts with the assumption that some pages are inherently trustworthy. And, most importantly, it assumes that those trustworthy pages are very, very unlikely to link to spam. So how does this actually work? It all comes down to another clever tweak of that teleport rule. First, a group of humans handpicks a seed set of trusted sites. Think major university websites, government pages, things like that. Now, when our random surfer teleports, they don't go to just any random page anymore. They can only land on one of these trusted sites. From there, trust flows outward from this core set, getting a little bit weaker with every link it has to cross. And this is the final checkmate. This is how you catch the spammers. By calculating both a page's regular page rank and its trust rank, the spam just jumps right out at you. A legitimate site, like a university, is going to have a high page rank and a high trust rank. But a spam page, it'll have a really high page rank because of the spam farm, but its trust rank will be almost zero because it's so far removed from any trusted source. That huge gap between the two scores is what they call its spam mass, and it's a massive red flag. You know, the whole story of PageRank is really this constant battle between creating order and trying to exploit it. The hyperlink was the web's original vote of confidence. But now, as we head into a world where AI can generate content, maybe even entire websites, you have to ask, what's going to be the next signal for trust and authority? What will be the next vote of confidence? That's a question we're all going to need to answer. Thanks for joining me for this explainer.